From Energy.Media, this is Energy Superheroes with Peter Perry. Hey everybody, welcome to Energy Superheroes. I'm excited to have today Kevin O'Donovan. Kevin brings a wealth of experience. He's a technology evangelist. His power talk on the future of energy was amazing. I'm excited to have him. Kevin comes from a very unique background in that he comes from a lot of the computer world, compact computer, HP, Intel. So he's very qualified to speak on digitization as well as the perspective of digital companies on the future of energy. Excited to have Kevin. Welcome to the podcast.
Thanks, Peter. Delighted to be here.
So great stuff. I just really enjoyed your power talk. It was tremendous. So you ran through a series of energy technologies that I thought were super unique and are going to be impactful to the future of energy. Can you rank order technologies? What's your number one in that whole group, or do you feel that they're all equally important?
If you look at the scope of the challenge with the energy transition, there's no one size fits all. So I do think it's not just digitalization, it's not just material science, it's not just chemical engineering, mechanical engineering. It's a bit of everything. And I suppose one of my favorite things right now is around energy storage. And granted, that's a big topic, right? Because again, well, how much energy are you trying to store? What are you storing it for and for how long? And you have everything from, lead acid batteries, which are still the biggest store of energy today, let's say outside of pumped hydro. And then you have lithium, and then you have all the different chemical combinations. You have flow batteries, you have flywheels, you have compressed air, you have people looking at using ammonia or hydrogen and sticking it in salt caverns for 12 months. So it kind of, people just go, energy storage. Yeah, we personal opinion, we have to have energy storage for the energy transition, but there's so many different types. So you could spend you could spend a year talking about them, right?
Very cool. Yeah, I mean, if we ever get energy storage right on a massive scale, we'll be in good shape. It's certainly taken a long time. Very unique that you point out that lead acid is bigger than lithium. I'll bet you not a lot of people knew that.
And that's simply because of, look around us in every existing vehicle we have on the planet, there's probably a lead acid battery in there today. Now, in some of the new EVs, maybe not because they're replacing it, but what percentage have we of EVs? Now, that's going to change. But even if you go into some massive power stations around the planet, they'll have a big set of lead acid batteries for black start and all this kind of stuff, right? So there's a lot of lead acid batteries out there, and they're not standing still either, right? They have advanced lead acid technologies and.
No doubt, no doubt. So I remember when I first found out you were at Intel, of course, I had to ask you if you ever met Andy Grove. But towards that end, who's had the biggest impact from a mentor standpoint on your thoughts about energy?
Woof. In terms of the art of the possible, it would be a bunch of different people. I'd follow different folks in the IT world and kind of the art of the possible, quantum computing. But I suppose in terms of one of the things that I kind of see as the easy bit is technology. And what I mean by that is technology is the easy bit. It's when humans get involved, it starts getting complicated. And the business model and the politics. And I must say, I suppose over the last, 10 years, so my background was in IT. Intel, we started looking at different verticals, and I had been working on green technologies and whatever. So that turned around that Intel asked me to set up and lead our sales and marketing into the energy sector worldwide. And probably one of the people that I started going, well, it's great having a cool technology, but you can't walk into a utility or an oil and gas company and go, I have a new widget. I don't know what problem it solves, but buy one. It's really good. And I suppose where I started watching for things was the folks at Bloomberg New Energy Finance kept talking about the technology is cool, but nobody cares. and folks like Jigger Shaw, again, with, the technology is, we've been using that for years, but you couldn't give it away. There's no business model. The regulation's not right. And. So I suppose, from a technology point of view, I have a list 50 people long where I kind of go, they're brilliant at this and they're that. But it's kind of bringing it back to the business model and people have to be able to use it. So there's, there's probably 10 or 15 people I kind of follow the blogs, and because I often say I don't know what I don't know. So you'll always find something new, right? And it's like, oh God, I had never thought of that. That's very clever. So
No,
it's
no
not that
doubt.
there's
And
one person. I'd have
that,
a
well,
long.
you mentioned Jigger Shaw, so we'll go with that. But you're you're
Well, Jigger has a new
you're
role now. He's off with the new administration.
very cool. I didn't know that. Where is he in the administration?
He's responsible for a lot of the new project development and funding around new technologies within the
Interesting.
Biden administration. So he's, let's say, kind of stopped all his previous things, and he's off there now, as you do.
Well, shameless plug for the government folks out there. If you're in the Biden administration, make sure you turn into Energy Superheroes to hear about the future of energy. So just had to throw that in there.
Well,
Um,
and if I may, it was at CERAWeek, John Kerry, the climate ambassador from the US, and obviously I'm here. I'm an Irish guy. I'm living in Europe, and we're doing stuff with the EU Green Deal and hydrogen economy. But I suppose one of the key takeaways from John Kerry was he said, we're not against fossil fuels, we're against the emissions. So back to carbon capture and right? Because I personally do not see us not using oil and gas over the next, I
of
don't know,
course.
number of decades. But we got to get a handle on the emissions. Otherwise, we have a whole different set of problems.
No doubt about that. So that's a great transition. I saw you commenting on Sarah Week a little bit. Other than John Kerry, what came out of there that you thought was particularly unique or interesting?
Everybody. So there was two things that everybody was talking about. One was hydrogen, and the other was carbon capture. And whether that was an oil and gas CEO from, it was a who's who of the oil and gas CEOs, right, worldwide, from Asia, Middle East, Europe, the US. Everybody was talking about carbon capture. Everybody was touting about the technologies that they've been using over the past 10, 15 years. But again, the challenge was that apart from enhanced oil recovery in some parts of the world, none of them are commercially viable. So they were
Yeah,
chatting about the fact, well, how do you create a viable carbon market, for want of a better word? Now, you can tax it, or can you create a kind of as a carrot or a stick? So the stick is your taxed cost of business, or is there a way? Can we use carbon? And what are the industrial processes like for within the cement industry where we can start using cement instead of, CO2 instead of steam? People looking at methane pyrolysis, where you get solid carbon. So can I use solid carbon as a building material? Can I build wind turbines with nanotube graphene stuff instead of steel? Now, some of this stuff is still science fiction, but I think it can't be just simply about collecting CO2 gas and sticking it down a reservoir. We don't have enough, right?
yeah,
So we got to find ways of using it, and that's the whole carbon economy. Then it becomes profitable to capture carbon. That
for
changes the
sure.
game completely. But this is so hard to do, right? And again, it's not the technology; it's the political will. And if 99 countries do it and one doesn't, then what happens? It's complicated.
Yeah, I feel like we're some number of years out with carbon capture, but you also mentioned hydrogen, and I'm hearing a lot of buzz around that. And I can, without mentioning names, I can say that several utilities I know of are near term implementing hydrogen fueled gas turbines. So we talk a lot about that here, and we love to focus on technologies that are near term getting implemented that have a chance to make a huge impact. And I'm excited to hear that they did talk about hydrogen over there at CERAWeek, because it is a
It,
really
it,
important technology.
hydrogen, I'd say, came up in almost every single session. I don't care whether it was a strategic session or a techie session. Hydrogen was everywhere, and yeah, like the likes of Siemens Energy, most of their gas turbines now are either between, I don't know, 10% mix, or some of them up to 50 or 60% mix, because it changes the burn rate and metal corrosion and. But yeah, they're you know, I certainly see, my personal opinion, natural gas is in many ways a transition fuel. And again, if you capture
Hmm.
the CO2 emissions properly with new technologies, then there's no reason why you couldn't keep using it for many years to come. But potentially you move over to hydrogen. And if the same infrastructure, if you build a gas turbine or a gas peaker plant today and it can burn hydrogen in the future, then you're kind of future proofing. Now there's a long way to go, right? But it's because it's not trivial. You can't just pump the hydrogen into the natural gas pipeline today and away you go. Bad things will happen. So there's a lot of work to do there yet, or burning ammonia and all this kind of stuff.
Yeah, for sure. What I love about it is it uses the infrastructure, let's say, model that we have today, which is a model of creating fuel and then distributing it. So it's I think it's an exciting technology. So glad to hear you mention that.
Mm.
Maybe let's transition into, as far as the new technologies go. What is the most exciting for you as far as the future of energy? That's, let's say, some number of years out there that maybe isn't on everybody's radar screen.
So the concept of making energy personal. And what I mean by that is, here in Europe, you'll hear people talking about energy communities. That's part of the European Energy Directive, where people, individuals, communities, towns, villages will have more control over their energy source and how they think. And what I mean by that is that I could have solar on the roof. You're living next door to me. You've got an EV. The guy down the road has a power wall or a sun and energy storage, or whatever. Right? Pick a technology, um, and we, as a bunch of neighbors, somehow magically our energy supply is balanced between us, because there's a bunch of little bits of software, potentially blockchain. It doesn't have to be, but you can call it a microgrid, a nanogrid, a energy community, whatever. But I do start to see that your street, so your feeder, for want of a better word, will almost become autonomous, and it will only start going back up the grid to go, I have loads of energy, or I need a bit of backup in the next whatever couple of hours because whatever, it's snowing here or something. So I do think that fundamentally changes a lot of, we there's a lot of discussion, and you hear people going, oh, if we put too much wind on the grid, it'll collapse. And then you have some countries in Europe where they have 100% wind on a given hour or day, and the grid doesn't collapse. Now, they've put a lot of technology into the transmission lines and the balancing systems to make that happen. It's not easy. But I do think the concept of, call them microgrids, and I just have an app on my phone and I go, I don't care, or it's almost just between us. We kind of, there's free energy. We just make sure we have enough, and that changes the way society and resiliency and. Now that sounds great in Western Europe and in some parts of America and the Western world, but if you look at a lot of the parts of the developing world, they're not putting in big grids. They're already going straight to distributed energy resources and that kind of a model. And if you look at kind of blockchain projects, you'll find a lot of them in Africa and places, because, again, you don't need the cloud back infrastructure, right? It's a distributed piece of software.
Great to hear you mention blockchain. I think it's a technology that has a lot of mystery for people. Maybe you could talk a little about blockchain and in the context of what you just mentioned, the personalization of energy, and even in the developing world. And then I'll follow up with some other questions about Bitcoin and such.
You have to bring in Bitcoin into everything.
We have to. It's just for SEO purposes.
In an energy discussion today, everyone goes Bitcoin. Yeah, a whole different world. So blockchain is a enabling technology. It's a software architecture, for want of a better word, right? We spoke about the World Wide Web, and it was HTML and web services and APIs, and well, the blockchain is just, at its basic level, it's a software architecture. And you hear people talking about, oh, well, I'll have a blockchain and I'll keep adding blocks of data. It's a distributed ledger technology, and ledgers, we all know, right, is keep writing into the ledger. But I suppose the difference is that when you write something into a blockchain, into that distributed ledger technology, you can never change it. So it creates all sorts of interesting things around traceability and making sure someone doesn't go back and, not that anyone would ever go back in and delete something out of a database or backdate it or whatever. But you can't do that in a blockchain, right? So everything is either happens or it doesn't. So you can do all sorts of traceability and when we talk about a blockchain and we add something to the blockchain, there's a piece of software that writes something into the blockchain. And that piece of software, we're all familiar with, especially in the energy industry, Internet of Things. So I have a device or a sensor and it's running a bit of software and it captures data and it does sends it somewhere and someone writes it. Well, blockchain is a distributed application, to be quite simple. And any one of those devices can write something into the blockchain. So you don't have to have the big cloud in the sky. You don't have to have the big data center or database in the sky. So it fundamentally it's a different way of programming, quite simple. But because it's immutable, and it's many of you hear people talking about smart contracts. Smart contracts is a piece of software that runs on your smart meter to do something, and the results are written in a blockchain, so no one can ever turn around and say that never happened or whatever. So it's a fascinating, but it is not the answer to the energy transition. It's simply an enabling software architecture piece of technology.
Yeah, that immutability is a very interesting concept. Could you talk about somewhere where you're seeing the blockchain implemented in the energy industry? Could be around immutability, could be around another functionality, but where's somewhere that you see it implemented?
So three key areas today. People talk about renewable energy certificates, and that's become a market in many parts of the world. There's a couple of companies out there using either the Energy Web Foundation's Energy Web or things like Hyperledger from IBM, where they've built applications, for want of a better word, so that when I go and buy renewable energy certificates, they're on the blockchain. So it's not that I can double count them and all this kind of stuff, and I can track them and. So that's a big thing. And companies like Flexido, and there's just many others out there. So that's a thing. There are renewable energy certificate markets out there that are based on blockchain. A second one is around supply chain, and that could be in any industry. But today, whatever, I mine lithium, or I make a device and I ship it across the globe. And as it's shipped around, someone's got a barcode scanner and they're scanning it. They're scanning a barcode and it's been stuck in some database in the sky somewhere. Well, instead of sticking it in the database in the sky, stick it in the blockchain. So again, it can't be deleted. So I know exactly where it was, and nobody can go back in and delete something, because in a blockchain, if you delete something, everything else fails afterwards. The whole the way it calculates the next block, if it finds one missing, the whole thing falls apart. So you can't delete it. So the ability to be able to trace things and know that it's the right piece of equipment and you know where it is, and so think of ESG, and the other angle is around cybersecurity. And what I mean by that is every time you update a piece of firmware or a piece of software, or you do a compliance check, if you record that on the blockchain, well, then it's recorded at that precise time and it can't be changed later. So if something bad happens, and when the insurance company comes in and goes, well, did you update everything? You can go on the block. You can say we did, and here it's in the blockchain. Whatever. It's not going to hunt the piece of paper from the clipboards. It's in here somewhere. I'm sure there's a filing cabinet over there. I'll find it in a minute. It completely changes that game. Now, it also changes the game in that nobody can go backdate something. It was either done or it wasn't. So it changes the compliance way of doing things in a big way, as opposed to the database or the piece of paper model. So there's three quick ones, and there's people using it for all sorts of other. It's an architect. It's like a piece of software.
It's very interesting. So it's going to make it a lot harder to fudge things, if I hear you right. It's going to make it very difficult.
It's either on the blockchain or it's not, right? And you can't go backdate something. It doesn't work. So that's going to be interesting.
The compliance people are going to be really happy. They'll finally get compliance.
Other people mightn't
be. So interesting. Well, of course, I have to bring up Bitcoin. Last I checked, it's over $50,000 a coin. I remember looking at it way back in, maybe it was 2011 or 12, when it was maybe 5 or 6 cents a coin. So the greatest investment of all time, that most of us missed, let's say. So Bitcoin runs on the blockchain technology. How does that work? And the reason I want to bring it up in this conversation is I'm hearing rumors of people taking energy assets and directly using those energy assets to mine Bitcoin now because the price is so high.
That is a thing. Using flare gas or excess gas, methane, for powering basically a small data center that's
Mm-hmm.
sitting beside the well. And one, so you use the flare gas or whatever to drive a small generator, and it generates electricity, and you use that electricity for some compute work. And one of those things is Bitcoin mining today. So let me back up a second now. So Bitcoin is a cryptocurrency. It's built on blockchain technology. But one of the features with Bitcoin is, so if I send you some Bitcoin, that's a transaction. In order to prove that transaction, it has to be written onto the blockchain. And cut long story short, because there's no one owning this, it's not one bank or whatever, it's distributed and anybody can do it. You have to give a reward to somebody to go do that, to write it into the blockchain, because they're not going to do it for free. And the way that the entire Bitcoin architecture has been set up is that there was this way of saying, okay, we need people, they call them miners, to verify the blocks. But the way that you'll verify the block is you need to solve a mathematical puzzle. And in order to solve the mathematical puzzle, you need a lot of compute power. And I'm not, you're talking a data center, right? Not a PC. And cut a long story short, a lot of people invested a lot in what they call mining rigs and data centers. They think Google data center kind of thing, right? With special mining hardware. And as more and more transactions happen, someone has to go off and validate those transactions. And the first 5 or 6 people that kind of crack that compute challenge, they get to write the block and they get a reward. So they get, I think right now it's something like 7 Bitcoin every time they write a block. So it's quite profitable, right? 50, whatever, right? So to cut a long story short, the feature with that is that that's what drives the integrity of the Bitcoin, because these people are proving and they're writing the blocks and. But the feature is that the way they run this incredibly high compute intensive algorithm to kind of say we're first, they call it proof of work. It uses a vast amount of energy just to solve an artificial problem that allows you to say, I got it, I can write the block, give me the Bitcoin. So there is a whole argument around the fact that Bitcoin is a digital currency, but look at the amount of energy it consumes. Now, if the energy is renewable or going to waste, you can have that discussion. We use energy for a lot of things that you could say we don't need. But yeah, in Texas right now, there's a lot of people looking at using flare gas and whatever as a way of, what do I use the energy I generate from? And Bitcoin mining is a thing right now. Now, it's not that easy. It's not that you're going to put out a container full of Bitcoin mining things and you'll make billions. It's really hard to be one of the first people to crack one of these problems, right? There's a whole economic model behind it. Does that make any sense?
You figure that at some point, price of Bitcoin, you could have gas turbines out in Texas that are peaking plants running all the time just to try to generate power to be able to mine Bitcoin if the price is high enough.
Potentially, yeah, you could.
And if the power prices are low enough, I'm not enough of a professional economist to figure out where the break-even point is. But I'm sure at some price per dollars per kilowatt hour compared to the Bitcoin price, it makes sense to mine the Bitcoin instead of sell the power onto the grid.
Yeah. Now, as I say, one guy with a well and a container full of Bitcoin mining. So it's not normal computers; they're Bitcoin ASIC miners. Blah blah. If you have one of them, the odds of you winning any one of the challenges are slim to none. You have to be part of a mining pool, so you kind of work with a lot of other people with a lot of other compute power and whatever. So that works. So to your point, there's the investment in the hardware, there's the cost of kilowatt hour, and then there's the probability that you're going to ever win in a mining pool or whatever. So there's you can go Google it. There's a lot of people out there with spreadsheets, and there are people like any business. there are business models around it, right? It's like if I was building a wind farm off the west coast of Ireland, there will be a spreadsheet you need to figure out whether you're going to make money out of it or not.
It's very interesting. I like to ask everybody who's the smartest person you ever met. For me, it must be the guy that invented Bitcoin, but but in your mind, I mean, it's just a
I'm not sure
brilliant.
anyone ever met him because they don't know who he is,
They
allegedly.
don't know he has a
Whatever.
fake name. He has a pen name. So brilliant individual, obviously. But in your mind, is of the people that you've dealt with, who's somebody that you look up to that's a really intelligent person? It could be in energy or in other areas.
So I came out of the IT world, and when I was growing up, um, probably Bill Gates was probably the most standout guy from my generation, right? I'm that generation. So like when I started out, I was doing OS2, and Microsoft were working on the first OS2 with IBM, and then OS2 went away and Windows appeared. Like OS2 was a much better operating system, right? This is going back to the late 80s, early 90s.
Yeah,
Um,
and a bit of
but
trivia. I think IBM was based down here in South Florida at the time in Boca
yeah,
Raton.
I actually was at IBM Boca Raton doing testing out their OS2 speech recognition in '93.
Very
Believe it or not,
cool.
they were
I'll have
trying
to
to
get a
test my
shout
accent.
out to a good friend of mine from high school, Scott Singer. He's the mayor of Boca Raton, and he actually just got called out in the Onion in the newspaper. And for Boca being so boring that they don't have to worry about lockdowns. But it turns out, take it from a local, it's not a boring place. It's got an amazing history. So I'll give a shout out to my friend Scott Singer. But anyway, I digress.
But no, I suppose like one of the most influential in the world of IT back in the late '80s, '90s. Bill Gates was kind of out there.
Yeah, no doubt, no doubt, and of course, Andy Grove is an amazing individual as well from Intel. Um,
Agreed.
so, are you still in touch with the folks over at Intel?
Oh, I would be. Some of my best friends are still there, and you know the reason I finished up with Intel, I when I was with Compaq, I moved. They moved after Compaq bought Digital, and we relocated the pre-sales team from Munich, most of us down here to the south of France, just beside Nice. So that's where I am today. That was 20 years ago. Cut a long story short, I went through the HP merger, finished up, joined Intel, and back in 2016, 17, Intel asked me to move back with the family, with my wife, to Munich. And my wife's German, and I came from Munich down here and whatever. But cut a long story short, south of France is not the worst place to live, so
I can
we decided
imagine.
to stay here. So that's how I left Intel. But it's a great company, and you know they have a new CEO. Pat Gelsinger is back. I did, you ask about some of the smartest people I've met or worked with. A lot of them will be in Intel. Some of the stuff that they do with the silicon design, and that's bleeding edge, right? It really is bleeding edge. And now what they're doing with AI and quantum and I still haven't got my head around quantum. Can't figure that out.
Amazing. Are they? So I'm sure they are, but would love to hear from you if they're doing anything specifically targeted at the energy industry.
They they do through a lot of partners. So I suppose if you look at oil and gas for years, high performance computing, so everything to do with seismic reservoir modeling. Now they have more competition these days with the likes of Nvidia and others coming along with the GPUs and but high performance computing was always a key thing. Um, when I was back with Intel or Compaq and HP, long before Internet of Things was a thing, we called it the embedded business because you were putting chips into embedded devices out in to measure something in the substation, in the refinery, in the wherever the pipeline. Um, so what's the Internet of Things? It's putting compute technology out at the edge and being able to communicate stuff back. So what Moore's law drove enabled IoT to be a thing, because if it was a CPU, a Pentium 4 CPU, we were never going to have sensors like we have today, right? So the whole, and what Intel did, what ARM did, Nvidia, others, that's where the Internet of Things. And then you take all the data and you create digital twins. And blockchain is a piece of software running on edge devices, right? So you wouldn't have had blockchain if you didn't have had the computer chips, and you wouldn't have 5G if you didn't have the computer chips. So that the whole silicon industry has been, in my opinion, a fundamental basis for a lot of the stuff where we're at today. And it's not slowing down, right? They're still going.
No doubt. I mean, that's really the building blocks of all the growth that we've seen. It's great that you brought up Moore's law, because certainly true. It would be great if we could get Moore's law to apply to battery technology. A lot of people said that it was going to, and I heard some smart people say that it wouldn't, and so far it hasn't. So we'll see if it ever does. But that would be good if we could get that same principle going in batteries.
Yeah, I suppose Moore's law, Gordon Moore from Intel, who coined that has been, what other piece of technology has had an exponential growth rate like that year on year on year? Now, some will say Moore's law is slowing down a bit, right? Because once you start getting past the 10, 7, 5 nanometer, it gets hard. This stuff is really small.
Understatement so of the really year, difficult.
Right? But at the same time, you do look at some of the 3, 4, 500% price decrease in some of the silicon, not silicon, the lithium ion battery technologies. You do see people now doing a lot more with floor batteries for long duration, Lockheed Martin and the likes, and many others. So again, people talk about sodium ion batteries, solid state batteries. There's a lot of clever people out there working on some new physical materials and mechanical property, and so I live in hope. I personally don't see technology fixing the climate issues we have, but they'll help mitigate. And one thing I didn't mention, but that's way out there. What happens if we get fusion working?
Hey, right? You never know.
Whole different ball game.
Whole different ball game. It could happen.
I agreed, and I'm a glass half full, and where I live in the south of France, ITER, the International Thermonuclear Consortium with the US, China, Russia, European countries, Asian countries, it's 300 kilometers to the west of me. But if fusion technology becomes real, then change the game,
game changer. So, well, Kevin, this has been amazing. We're about at time here, but before we go, I would love to ask if there's anything that I could have asked you that the audience needs to know, or anything that you'd like to plug. Would love to hear your closing thoughts.
Well, if anybody wants to get in contact with me, they'll find us through Twitter or LinkedIn. My day job is actually helping companies understand some of this technology landscape, because if you're a C-level executive in any energy company out there today, there's so many buzzwords coming at you that it's like, hang on a second, what is that? And whatever. So that's what I do in my day job, help companies try and understand what's coming at them. Not that I know everything about every technology, right? That's just impossible. But at least I can spell the name, hopefully.
No, but you've got an unbelievable broad understanding of all the technology. So
it's kind of I call it joining the dots. And again, to be honest, we're only scratching the surface on some of this stuff, right? So it is fascinating. But no, it's going to be, if you think technologies and the way we're advancing with the technologies in the energy transition right now, if you think it's fast now, buckle in, right? Because with all the stimulus dollars across the globe, and whatever you think about COP26 and the carbon zero, net zero targets, whatever, there is money being put at this, and there's a lot of clever people. So if you think it's going fast now, buckle in. It's only going to accelerate.
Agreed.
It's going to be an interesting couple of decades.
No doubt about it. I love to talk to somebody like you that comes from the background in the tech world, sees the same thing I do, which is now energy is really the hot place to be. I'm excited to be a part of it. And it was great having you on the podcast today, Kevin. For all of the bigger companies out there that are looking for somebody that can really help teach them about the future energy technologies, make sure you reach out to Kevin. And I'm sure that you will not be disappointed. Kevin, thanks for the time today.
Thanks, Peter. And hopefully we'll meet up in person in the next, 6-12 months.
We got to make it happen. I think we're getting there. Things are looking
Oh,
up.
again, we'll get there. It's just we'll get there.
We'll be there eventually, no doubt. Thanks, Kevin.
Cheers, Peter. Thank you.
For more energy superheroes with Peter Perry, visit Energy.Media.